Welcome to today's webinar on Earthen Manure storage systems. My name is Thomas Harrington. I'm an agri-environmental specialist with Perennia Food and Agriculture. As host, it is my privilege to welcome you here today to today's webinar, and I want to thank you all for taking the time to join us here today. So with that, let's get started. We will start with just a few Zoom housekeeping items first. All participants will have their audio and video turned off to prevent background noise during the webinar. You are encouraged to ask questions, so please use the Q&A feature at the bottom of your screen. These questions will be monitored during the presentation by our team members and verbally asked at the end of the session. You can also use the chat function, but this will be visible to all participants to comment and respond. Before I get to our guest presenter, I would also like to introduce my co-host today, who will be assisting with the Q&A and help address any other questions. I am pleased to have joining me today Environmental Farm Plan Coordinators Corey Roberts and Trevor Davison. Also, before we begin, I would like to give a brief introduction to the new Nova Scotia Agri-Environmental Program, or AEP. The Agri-Environmental Program is a partnership between the Nova Scotia Federation of Agriculture, the Nova Scotia Department of Agriculture, and Perennia Food and Agriculture. This program combines environmental components from each of these organizations, building on their individual strengths. The AEP provides comprehensive and relevant information to help reduce environmental risk on farm. It also increases public trust and expands market access through 4 foundational pillars. This program is funded through the Canadian Agriculture Partnership, which is part of a commitment by federal, provincial, and territorial governments to promote productivity and profitability for the agriculture sector. Please learn about this program by going to our brand new website, which is located at www.nsaep.ca for more info. This web series is an initiative of the new Agri-Environmental Program, and its aim is to provide new and relevant agri-environmental information to the industry. Today, we are going to be learning about earthen manure storage systems. These types of manure storage systems are widely used in Western Canada, but less commonly in Nova Scotia. We are going to learn about how the structures work and if they might be a consideration for your farm. We will also discuss various aspects, including design, siting criteria, and environmental elements. I'm pleased today to welcome Engineer Steve Brogan. Steve is a professional engineer and designer who specializes in design for food and agricultural systems. Prior to starting Rural Roots Engineering and Design in 2014, he had a career in both consulting, engineering, and academia. After attending undergraduate studies at NSAC and the University of Saskatchewan, he worked for consulting firms in Western Canada and the United Kingdom. His academic career saw him teach engineering courses at the Scottish Agricultural College in Aberdeen, Edinburgh, and Dalhousie, AC, where he also completed a postdoctoral fellowship. In 2012, he graduated with a PhD in design from the University of Dundee in Scotland. Steve's primary focus has been to develop modern, innovative solutions for rural-based projects in Atlantic Canada. He is a registered professional engineer in all 4 Atlantic provinces and has had the pleasure of working in almost all aspects of food and agriculture in the region. We are very happy to have you here today, Steve, and I'm going to pass it over to you.
Thank you, Thomas. I will now get my screen share started. Okay. We good?
Yes, looks great.
Perfect. We'll get started. Oops, full screen here. There we go. So I think Thomas did a pretty good job of introducing you and or introducing me and getting the academic and professional stuff out of the way. So I want to just give a little slide here. I jokingly referred this to name dropping. I'm by no means a world expert on manure storages, but I have had the pleasure of working with some really world experts, including Doug Small and Dennis Hodgkinson, who were my professional mentors when I graduated from university and started working at DGH Engineering in Winnipeg. Doug, you'll notice if you're familiar with the PEI manure regulation or manure guidelines, he was one of the authors of those, and he was also the primary lead on the tri-provincial white paper committee in the Prairie provinces back in the 90s. One of my dear professors at the University of Saskatchewan was Terry Fonstad, and I lost the wonderful photo I have of Terry that he hates, that I always show everybody, and sadly it's lost in the sands of time. But Terry is currently a professor in the civil engineering department at U of S and specializes in earthen storages, and has done a tremendous amount of work on liner efficacy and longitudinal studies in groundwater and all that kind of good stuff. So I have a good group of people I know. Let's put it that way. And while I was working out west, I had the opportunity to project manage and lead engineering design on many storages. These were a retail item for the company I worked for. So those of you who, I'm assuming not many, or many if none of you listening to this are engineers. Many of you might be Aggies, and I always explain what an agricultural engineer is. And it's a little bit, someone once asked me, or someone once gave me this wonderful analogy that a fox is a dog running cat software. So it's a little bit, if you can understand that, an agricultural engineer is an engineer running Aggie software. So I'm not an Aggie. I do not have a degree in agriculture. My background is engineering, but it's all to do with agriculture. And then for those of you who, I like to say this is one of my favorite quotes. It's E.H. Brown. He refers to this, he's a structural engineer, and he said, engineering is the art of modeling materials we do not really understand into shapes we cannot really analyze, so as to withstand forces we cannot really assess in such a way that the public does not really suspect. So I thought this was particularly appropriate dealing with earthen structures. And we'll touch on how we deal with that uncertainty and what it means from a practical standpoint. People understand wood, concrete, and steel as engineering materials, but there's probably it's a little less intuitive how we use dirt as an engineering material. So the kind of 4 high points, or 3 high points here for outcomes on this presentation are, hopefully by the end of it, you'll be able to point your finger at something and say, that is an earthen manure storage, and know what the different parts and pieces of the storage are, the terms, and some of the standards that we use. The second part is just kind of compare and contrast with the other options out there, steel and concrete being probably the most popular for liquid storages here in Atlantic Canada. And then last, I look at applicable legislation, regulations, and guidelines as they sit right now here in Nova Scotia. What I'm not going to talk about is how we size a storage, or get into any of the details of other earthen manure storages. There's plenty of great information out there, including the Nova Scotia guidelines that give you really good idea of this information. So if we look at what we needed in manure storage to do, it as a structure has to resist the environmental loads. These are forces such as soil pressure. So, if you've dug a hole in the ground, there's force of the soil pushing in. There's wind that blows. And in fact, you can have icebergs in your manure storage, and in designing concrete storages, the force of ice is a big one to consider. We also need to be able to carry the rain and snow that are going to inevitably fall into it. In addition to this, there's service loads. So if you're unloading the manure storage with tractors, machinery, pumps, mishaps. Sometimes the foot slips off the brake and goes on the other pedal, and you've got a bang into the side of it. So we've got to look at this. That's what the storage needs to do structurally. It also has a really important job to do environmentally, and that's the liner. So I've kind of broken the liner out as a separate thing, and conceptually you'll see why I wanted to do this as we go on. And ideally, we want to store the manure. We're not building a manure storage colander or a filter, or we want to make it a nice sealed tank, for lack of a better word. So we want to prevent that liquid component of the manure from entering the surface, or spilling over into the surface and getting into ditches and streams, or leaching through the ground and contaminating groundwater. In the world of manure storages, liquid manure storages, we'll talk, maybe brush on solid storages a little bit, but an earthen storage is one that is made of earth, where the structure is made of earth, and the liner may be made of almost any material. So keep that in mind. The liner may be made out of different things. It doesn't have to just be an earthen storage with an earthen liner. A concrete storage, which you might be familiar with, a square or circular tank, will be made of concrete and lined with concrete. And steel would be the same idea, and often the steel will have a vitreous, like a glazed coating to it, like you'd see in a slurry store, to protect it from corrosion. So first things first, an earthen manure storage is an engineered structure. And I've kind of taken the liberty of saying, if it's just a hole in the ground, it's just a hole in the ground. An earthen manure storage is an engineered structure. And you'll see there, that's a picture of a pretty big pig farm in North Carolina. And the picture on the right is a hole in the ground. So let's look at the different types of liners. So we'll go through the different types of liners that are applicable for earthen storages. The first one would be a clay liner. Now, some soil scientists sitting here listening to this maybe will know that a lot of what we call clay in Nova Scotia isn't really clay. You couldn't make a brick out of it or rub it into a little worm and bend it. It might be a clayey silt or a silty clay or something. So keep that in mind. An earthen structure lined with clay, you're using the clay as an engineering material. So it's lined with remolded clay. So if you were to look at this, just a general little diagram here, you'll see that in the, I can use my pointer, this part here is different color than this part. This is just soil. This is just whatever the material is that we've got on site. This here is clay. So if you're lucky enough to have clay in situ or in place, you can take that clay out and you can place it down in 6-inch lifts and compact it with a big roller with pads on it, squash it down, test it, and then part of that process is, you have to make sure you know what the clay is. So in this case here, we've probably gone to a lab and we've done a falling head permeability test on it, and they've remolded it to know what we're dealing with. So in this case, the clay is an engineered material. It might be just the stuff that you have on your farm, or maybe you have to open up a borrow pit. You've got a couple acres up the road and it's good clay up there. We truck it in and we use it. So it's remolded liner. And like I mentioned, in order to do the engineering on this product or on this system, we would want to do some geotechnical testing. So we would do in situ soil properties. We take tests of the material. Okay, what are its workability limits? So, some soil's interesting stuff, and sometimes it's gets a little bit of moisture on it, and it just turns into liquid. Other soil, you can put a lot of moisture in it, it doesn't move. That's more what we're looking for this. So we do liquid and plastic limits. We'll look at, and then we'll look at a remolded permeability. So in the lab, they're going to take that soil. There's several labs in Halifax that do this, and they're going to whack it down with a little special whacker. I don't know what it is, but they'll make it in. They'll compress it into a cylinder, and then they'll put water on top of it, and they'll look at, okay, it's now reached saturation point. What's its permeability? So that's how we assess its effectiveness as a liner. And then when we're building this system, in order to have quality control, we'll do on-site compaction testing using a nuclear densometer. So as they go around and they lay the clay down, it's compacted with a big roller. They'll take a machine and check and make sure that proctor density is the same as the one that was done in the lab. So pros and cons of clay liners. They are really low cost, definitely. It's just material that you have on site that you're going to be moving anyway. They're all natural. They're easy to repair if you have a blowout or something, or some erosion that happens, and they're relatively foolproof. So a clay liner will be no less than 1 meter or 3 feet roughly thick. So you've got quite a thickness there to work with, meaning that, you know, if you have an oopsie with a loader, it's not probably going to slice through your liner. The cons are really in our region is that you may not have this material available to you. That's probably the top concern. I've done a couple, maybe 3 clay line lagoons. Well, I would say 3 big earthen storages since I came back here to Nova Scotia, and where we thought we had it, we didn't, and where we didn't think we had it, which was good. So just be aware, we can't use even the clay. If the clay has boulders in it that are that big, it's not going to work. And the other con too, there's a geotechnical testing requirement. Not that it's incredibly expensive given the cost savings of using the material, as opposed to $200 a yard for concrete. There will be a few $1,000s worth of geotech testing. Second type of liner we're going to talk about is a geosynthetic liner. This is kind of an interesting product. So looking at the diagram here, you'll see the black line is the geosynthetic liner, and it's only about that thick. It's only, in fact, here's the best pictures I could find on the internet here show what really, you know what it looks a lot like? Kind of like car mats or carpet that you would find in your truck or your car. It's porous, but inside between the 2 layers is bentonite clay, which is really a high swell sealing clay. So you're using a natural product that's combined with a man-made product. The advantages, so that's how it goes in. Now you'll notice that there's a layer on top, which is going to have a cover material, and that could be anything. Sometimes you use a lightweight poly, or you could use native soil material. And the obviously cheap, it's not acting, and the native soil would not be acting as a liner in this case. That it would just be acting as a protection for this stuff to keep it from the sun, wind, and rain off of it. So it is a manufacturer product. So when you install it, the engineering is pretty straightforward. It comes with a specification. It'll tell us how, what kind of slopes we can use, anything that the manufacturer requires for protection, coating. It will require on-site fabrication. It's obviously going to have to be stitched together in some way or another. And there'll be quality control. So the people that install this, it wouldn't be a DIY project. You would have somebody like Atlantic Polyliner or one of the other environmental and big civil environmental contractors do this kind of work. People that do municipal lagoons, the these liners are often used in town and county dumps, that kind of thing. So pros and cons, it's a pretty easy install. Just roll it out like carpet. However, it is going to be clearly more expensive than the native soil material, remolded clay. And it can have reactions to, so if you have a soil that has it's particularly chemically active, you know, and it can transfer the ions. And I'm getting a little technical here, but soils people will know what I mean. It can basically take that clay and make it, it reacts with the clay, let's put it that way. So our last style here is a synthetic liner. I have quite a lot of experience with these working in the West. In Western Canada, typically there's a lot of clay, and that's our first option. But in places, especially getting into the Alberta foothills, you have more loamy and sandy soils, and this is what we would use in those applications. This is also a really widely used product in civil engineering all over the place. It's 30 mil PVC or 60 mil HDPE. Polyvinyl chloride, HDPE is high density polyethylene. I have a piece of it sitting here, which is just out of my reach. It's not thin. This is not like a tarp. This is stuff that's 4 times thicker than a crazy carpet. Like, it's not very bendable. This is pretty heavy stuff. It's set up essentially, it goes directly in contact with the product in the storage. Now, installation on these is very much a specialized trade. It's done by ticketed welders, so HDPE ticketed welders. They use a welding machine. It kind of looks a little bit like a bag stitcher or a big sewing machine, but what it does is it welds 2 beads along the seams, and they actually pressure test it. So in between the 2 beads, they inject air and they'll pressure test each seam. It's a very, very let's say you can count on it being sealed up quite well. So it's definitely an engineered product, but very straightforward. The pros here, it's widely used in industry outside of agriculture. It's used all over the place in any lining, stormwater management ponds, municipal waste treatment plants. You'll see it underneath a gas station, tanks. It's all over the place. The cons here, and I didn't write on the slide here, but this will be probably your most costly option compared to the other two. Definitely requires professionals, and you need to vent this thing. I don't know how well the slide's coming off or broadcasting. It depends on how big your screen is. But in this picture, what I've shown are what they call whales. They look just like a whale. And what's happened here is that liner has come up and made a bubble under it. I don't know. Sometimes you get that on a pizza. You get this bubble of dough, and it moves your toppings all around. This is what's happening here. That's because these need to be vented. The soil sometimes has gas in it, and that gas can cause those to happen. And it looks ridiculous. It reduces the storage capacity of your storage, and in addition to that, will cause, could eventually lead to a tear. I'm going to throw in another option here. Those are the 3 main types of liners I wanted to talk about. I want to talk a little bit about concrete features. I got this picture off the internet here, and this is a clay-lined lagoon with a concrete base. So I'm going to take a guess. Just my spidey senses tells me this is a dairy barn, and if I were to guess, they probably are going to be using sand bedding. If anyone listening here knows what sand-laden manure is, you'll know why they want a ramp, because that's going to be something, the sand is going to develop a little sandbars and a little beach in here. I'm guessing that's why they have ramps. Any type of manure storage, whether it's a poly-lined or clay-lined, anything, you'll usually want to have, well, you will be required to have erosion protection anywhere where the pipes are coming in or going out. In addition to this, I've seen concrete docks where we have basically a dock like you would see in the ocean, comes right out to a vertical drop down into the storage, so you can use a vertical manure pump if you have one for use pumping out concrete system or whatever. Another option, a little add-on you can do here is, oh, by the way, I'm just going to come back to this. This is clay lined. You could do this with a poly-lined lagoon too. You can put concrete right on top of the poly liner. Looking at the covers, the company I worked for in Winnipeg had a patented negative air pressure cover. This isn't one of their covers, but basically how it works is there's one here in Nova Scotia that we designed 4 years ago. And essentially it's a light PVC, or it's like a 30 mil HDPE cover, sits on top. And there's an extraction fan similar to what you'd see in a furnace blower, perforated pipe around the perimeter, and it's keeping this under a negative pressure. So when the gas builds up, it just vents out. These systems use an air agitation grid on the bottom to agitate the solids out when you want to pump it out. I can go into a lot of details in this, but generally speaking, the advantages really are keeps the rain, snow out of your manure, so you're moving less when it comes time to spread, and it reduces some of the volatilization of nitrogen-based gases that are ultimately fertilizer for you. So, rules of thumb here. People always ask, well, how much does it cost? And the answer is, how long is a piece of string? Generally speaking, I can give you comparisons between the different options, and this is a pretty accurate description of what your cost per unit storage volume is. So your cheapest is going to be clay lined, then a synthetic lined, a round concrete tank, a square concrete tank, and steel. Now, there's going to be some difference in the cost spread based on the size of the storage. Small storages, you're going to see not a lot of cost per unit difference between these. And as the storage gets larger and larger, those cost spreads become quite substantial. And your actual net savings, if you were to come to me and say, you know, I'm thinking of a round concrete tank versus a square concrete tank, and you're only looking at doing a 30-foot diameter tank or something, then they're going to be about the same price. Same thing here. One of the things to keep in mind, anything you put in the ground is going to require you to dig a hole. So really, when it comes down to it, plus or minus, you have to look at what the liner costs, and that's really what's going to drive the price. To reiterate my point there, the bigger the storage, the bigger the savings. We did a lot of work in Western Canada in the hog industry. They have large lagoons, often multi-cell for separating solids and liquids. And as far as I know, there is only one, our company was only involved in one concrete storage in the hog industry, and that was at the Prairie Swine Center, which is a really small one. I got this picture because I Googled for the biggest one. That would be a Midwestern United States dairy. Look at that barn. Look at the size of that. I don't know if you can see vehicles on there to give you a scale, but these lagoons are sized in acres. Those are covered earthen manure storages. So the second thing is, you know how much it costs. It's a cheaper option. What about operating? Well, here's a big consideration, and this is an important thing for our climate. A typical earthen storage will capture about 20% more rainwater than a storage that has completely vertical sidewalls. This is an uncovered one. So I kind of pulled an example out of my drawings here. 110 foot by 13 foot round concrete storage that has the same nameplate capacity or storage capacity versus a similar earthen storage. You're basically going to collect around 36,000 gallons more water over the course of your 7 months. Well, actually, I fudged this a little bit, okay? It's going to collect 36,000 gallons more water annually. So that's, if you have a 6,000 gallon tanker, that's 6 more loads. This is where it gets into some of the is it right for me questions, and really one of the most important things to ask yourself is about spreading. If you're on a small farm, it's a small storage, and you have a small tanker, just consider that. One of the other, so that's kind of your biggest downside here, is it's going to collect more water, and in our climate, that's a factor. But put those numbers to a calculation, and I think you'll find a pretty good value. Is it like everything else? As the size gets bigger, those numbers sort of disappear into the background. One of the big factors we see in the dairy industry here is the use of sand bedding, and there's a substantial cost to clean out a concrete tank with a long reach excavator. That's something that needs to be considered as well. I know a number of our clients have just purchased the excavator and used it on the farm because it's definitely been an issue for them. Whereas earthen storage, you might be able to build a ramp in and deal with that without purchasing a large piece of equipment. Let's look at environmental. So this is something that I have a big interest in. This is one of my, I guess, academic interests, maybe. This is something I hear a lot, and this I guess we're myth busting here. So permeability, this is the ability for the liner to withstand liquids going through it. Clay is more permeable than concrete, just as steel weighs more than wood. What's stronger? It's the old a pound of feathers versus a pound of lead. Which weighs more? They weigh the same. So with concrete versus clay, the comparison is that they perform the same, or clay will typically perform better over the long run. And the reason is concrete cracks. So you can assume that your concrete has a permeability of X, but that's under ideal conditions, and concrete cracks. Just so happens, sideline here, my father did a lot of work in the oil industry, and he was in non-destructive testing for a period of time, and he worked at the Imperial Oil plant in Halifax or Dartmouth for a period of time, and they had a concrete oil tank. It was built, I want to say, either direct around the Second World War due to a steel shortage. That tank leaked a lot of oil. It had a liner around it, and they just pumped the oil back into the tank because concrete leaks, concrete cracks. So clay liners, on the other hand, are self-healing, and they don't tend to, the long-term environmental performance is typically better. Now, we're going to go into some regulatory stuff. Now, I've got to make it clear here, regulations, guidelines, we're going to talk about them, and they're a little bit different. and these are always in flux, and they're kind of an interesting thing. So I'm going to give you some experience. So starting my career in the 3 prairie provinces, we did work in all 3. And generally speaking, they had a little bit of a different method, each Manitoba, Saskatchewan, and Alberta, of regulating manure storages and the CFOs, they call them, confined livestock operations. But typically, there's a permit process. So if you want to build a storage of any kind, concrete, earthen, steel, or even you want to build the dairy barn and it's got a cross gutter in it, that would be something that requires a permit from the provincial government, and in one form or another. Some of the provinces administer that through their Department of Environment. Some administer it through their Department of Agriculture. In the case of Alberta, they have a third party. It's a government board called the NRCB. So what you need to submit when you do one of these, and I've done many of these, is a calculation for a minimum number of days of storage. So you've shown them that you're going to, in fact, yes, have enough space to store whatever is being produced by the animals. There'll be a site geotechnical investigation, including sinking boreholes, so we can know the soil stratigraphy. That's the different layers. You've got clay and sand, and oops, okay, there's a water aquifer under there. We need to know that. So that's all part of the investigation. There's a detailed engineering design. So that would include things like what kind of liner, what are the specifications, what are your projected permeability, how are you going to, basically address those design considerations. We also would need to submit quality assurance program. So we would need to make sure, okay, NRCB or Manitoba Environment, what are we going to do? So I'm the engineer. What am I going to do to make sure this thing is built as per my specifications? So I would usually put together a supervisory report. So we would do site or we would do progress of construction inspections. We would make sure that the guy, if we're doing a poly liner, you got ticketed welders, he's doing pressure tests, so on and so forth. And then at the end of it, we'll install permanent monitoring wells based on the site investigation that should tell us roughly which way the groundwater is flowing. So we'll have monitoring wells so that we have an idea of where the water is. And then before the manure is loaded in, we'll do baseline water sampling. So we'll bail the wells out, take some water samples, we'll get nitrogen, BOD, COD, all that information off the water. And then typically the permit that we've been issued would give us a requirement for, or not, ongoing sampling. So if you're in an area where, we're not too worried about the groundwater here, it looks like you're 200 feet before you hit any aquifer, don't worry about it. If there's a problem, we'll come and we'll bail your well and see what's going on. Or some places they might be an environmentally sensitive area. The farmer will be required to do annual groundwater sampling. So as you can imagine, this is a few weeks of work, a 30-page report, and a fairly long-term commitment from the producer. And each province in Western Canada has their own written code for storages, that 3 or 4 pages, that things like minimum liner permeability, stuff like we have here with setbacks, so on and so forth. In that environment in Western Canada, the regulators such as NRCB, different environment departments, or in Saskatchewan's case, the Saskatchewan Department of Agriculture, work quite a lot with industry and academia. And they do things like this. So this is a report written by Lee Barber and Terry Fonstad this is a really good report if you're a manure storage geek. It is really neat. And it goes through everything from regulatory environment in Europe, Ontario, Quebec, Atlantic Canada, US, and talks about, basically they went around and they bailed monitoring wells, and they said, this is what's happening. Here's what we're doing. And they very much have a work with producers, work with industry, work with academia. There's a fairly good back and forth. And this is in contrast to what I'm going to call the don't ask, don't tell policy that might be a little more typical of what we see in Atlantic Canada. So, first statement here. In Atlantic Canada, there is no regulatory framework for manure storages. So, be aware that there are guidelines, there are industry practices, there are definitely things like the Environmental Farm Plan that my 3 people here on the board are also quite well involved with, but there is no one that will come to you when you build a manure storage and say, give me the engineering, let me have a look at this. No one's reviewing it, and there's no monitoring process. So I kind of went through, and as far as I can tell, I've dug the following up off of my experience working here. And in addition to that, what I could find on the various websites. So in Nova Scotia, we have guidelines that were issued by the Department of Agriculture back in 2006. I understand that they are probably coming close to being finished, the review process. I know Julie had sent me an email a year or 2 ago, time flies, that they were going to be updated. So these are undergoing revisions. If you're a pork or a mink producer, you are under a different regime, I guess. There's different rules. PEI, they have quasi-mandatory guidelines, and this is a little bit different. So when we do storages on PEI, they have the guidelines that they wrote in 1999 that my old boss, Doug Small, worked on. These guidelines are not written into regulations in an act. They are still called guidelines, but they do have an approval process through their building inspection department where there is a person at PEI Agriculture that will review the submitted design to make sure it meets the 1999 guidelines. So you will not get a building permit for your manure storage unless you meet the guidelines. So they are not written into law, but they're in practice essentially. Newfoundland has similar to Nova Scotia, there's non-mandatory guidelines. There's no mechanism there to, there's just no mechanism. There's really, in City of St. John's, yes, but we've done dairy work in outside of Deer Lake and do whatever you want. New Brunswick used to have guidelines like we do here, and they were withdrawn. And the reason why, and when I asked them, because we had this discussion about, they have a similar program, and I'm losing the name of it, but you know, with where there's a funding for environmental work on like up to $30,000 over 2 years for environmental improvements on your farm. So I asked them for their guidelines. You know, here in Nova Scotia, in order to get that money, we would want to make sure we were abiding by the guidelines. And in New Brunswick, they withdrew the guidelines because their lawyers felt it became one of these situations where it was, they didn't want to be seen to be making the rules they couldn't enforce. So they withdrew them. Here's the on the ground reality. So we come onto farms if someone hires us to do a manure storage. The typical way of doing that is we'll do up a design to our best practices, usually exceeding what the guidelines are. And we will, every municipality is supposed to require a building permit. Only one municipality in Nova Scotia I have ever submitted for a building permit for one of these. They really are not well understood as a structure by the building officials. I'm not incriminating anybody. If you hired me to fix your manure storage, great. Have I seen things that are kind of sketchy? Yeah, leave it at that. So I'm assuming that if you bring me in to fix it, great. But I've seen some stuff that was, whew, let's leave it at that. So our guidelines, very good book. It's very producer friendly. You can crack that sucker open and it's not got a lot of jargon that would throw you off. It's definitely, it's very holistic. So they approach things, everything from setbacks to lots of information in there on calculating the size of your storage, siting it, so on and so forth. However, when it comes to earthen storages, I have copied the entire section here in this, which says, a qualified engineer should do the preliminary soil investigation and design the storage before any construction begins. Okay, so that's what the guidelines say. Yes, I agree, a qualified engineer should. But what do we consider a soil investigation? What do we have for performance regarding permeability? It's left up to the discretion of the engineer. And my go-to is using a standard from one of the other provinces. They're all about the same, but there really isn't a, there's no guideline on what the performance requirements are of an earthen manure storage. Okay, so down here, enforcement is basically if you get a complaint. So if somebody calls up and says, I don't like what's happening, you would be talking to Nova Scotia Environment. So this would be the same kind of hotline you would call up if you saw a leaky oil drum or somebody throwing a stick of dynamite into the river to fish. You could call up and complain to them. Not that I don't work for Environment, but I know in my dealings with them, they don't have a lot of complaints related to manure storages. They often have complaints related to manure spreading, which is something different. And I'm aware the Farm Practices Board deals with this as well. So what if you own one of these hole in the ground things? I'm not here to sell you sleep enhancers, but if you're really worried about it, these are the things you might be thinking about as you're lying in bed at night, not worrying about all the 50 million other things that you worry about when you run a farm. But the question is it leaking? If somebody says your manure storage is leaking and has contaminated my well, how do you know? Is the water there naturally high in nitrogen? Don't know. One of the things is these things are very much ticking time bomb leaks where there are manure storage related groundwater problems. They do move fairly slowly through the soil. So you could have a problem with a leak 10 to 15 years after it happened. Something I'm going to have a little aside with right now is, just checking my time here. Okay, we're good. One of the things I just wanted to say is there's just a little concern with basically time on these things. So manure storages can bioseal, and you've probably seen that if you own one. Basically, they just seal themselves up. What's the permeability of a bioseal? Depends. It probably changes week to week because it's basically a living little scum layer. But sometimes I've heard of people where they dig a pit, they'll fill it up, and then first 2 or 3 years, they're losing a lot of the liquid out of it. Then it sort of seals off. In those cases, that liquid went into the ground. Do you remember the ad that used to be on back in the 80s? And there was a guy on the fishing boat, and he chucks a piece of garbage overboard. And his son says, "Where'd that go, Daddy?" "Away." And that's a little bit like the water that might have gone into the ground. Where did it go? Well, it went away. Reality is that plug of nitrogen-laden water could be moving through the soil very, very slowly, like the Titanic and the iceberg. Who's responsible if there's a leak? Well, don't know. What is the potential impact? Could be very little, or it could be someone's very sick and dies from contaminated well water. And the last thing is, who asks, who tells? This is probably where we're at right now. So I want to just kind of end this a little bit with some philosophical questions about regulation here. What drove it? In the prairies, it was the pork industry. It exploded in the late 80s and early 90s, and pure and simple, people smelled things and they complained. And the industry developed a strategy. They worked with various levels of government, and they wanted to get in place regulations that would help guide them in the event. I mean, you can just go on Google and look at issues that have been arisen around pig farming. And they went for a science-based. So, they went in and said, okay, if we're going to do this, what's our permeability of a liner? What should we allow for permeability on a liner? And they wanted to be industry driven. So this was something that was like, okay, we're going to do this, and this is what we're going to do, and this is how we're going to have a result. And I contrast this a little bit with what happened in Ontario. Ontario was much like Atlantic Canada, and really until Walkerton happened. Without retelling Walkerton, it was essentially, there was a bad water treatment plant, and it wasn't being run properly, and some of the wells were near animal fields. There was surface water contamination due to a poorly bentonite sealed well. There was a E. coli outbreak. And so really that was a tragedy. It really was. And I mean, someone recently died just a couple of years ago due to Walkerton. Still recording deaths on that one. Really a terrible tragedy. And so what ended up happening, a lot of lawyers and a lot of government people came in and imposed regulations. So I'm calling that reactionary and lawyer-driven legislation. I'll leave it to your mind which one is probably better. So, earthen manure storages, EEE, engineered, environmentally friendly, and economical. No, they're not for everybody, but give them a shot. They're definitely a really neat type of system. And I'll leave you with my last, with the cookie. We're not having milk, cookies, and coffee after this, so here's my cool little thing. I'll leave you with a metaphorical scoop of ice cream. I worked at the Scottish Agricultural College in their consulting. They had a company called SAC Environmental, and we did exactly what I do now, engineering consulting. And this was one of our clients, Mackey's. They're outside of Aberdeen, and this is a storage. The owner of this farm recently passed away. He was P.T. Barnum of dairy farmers. Like the guy was larger than life, and he did a little bit of everything. He had a farm down here. You'll see this is the top of a big hill. The bottom of the hill, he had about a 300 head dairy. They had a ice cream plant where they manufactured ice cream. He had hog operations over here. He also had potato operations, and he manufactured his own potato chips. And he has haggis flavored potato chips, which are really good. You may or may not like haggis, but you probably will like haggis flavored potato chips. Anyway, Maitland Mackey, I got to do some work on this farm, and this was an earthen manure storage on the top of this hill. Those are 2 wind turbines. He makes all the power he needs to manufacture his ice cream. And this entire farm, which is probably about 600 acres, is irrigated with wheel move irrigation lines and all with manure. So he's got, this is dairy and hog manure up here. So this is my favorite. It's very elegant from an engineering perspective. They pump uphill and they gravity everything down. So they're neat. The end.
That's excellent, Steve. Corey Roberts here with the Environmental Farm Plan. Great presentation. You've raised some really good issues, and I know we're kind of getting a little bit short on time here, but we do have a single question that came through, and I'd like to pass that along here. And the question came from Havy Witten, and that was, how durable are the liners with regard to aggressive mechanical agitation?
Okay, well, that's a good question, because mechanical agitation is one of the loads that we very much consider. So one of the requirements for a clay liner is the liquid and plastic limit. And that kind of, if it's the liquid limit is too high, that clay is going to erode very fast. So for a clay liner, the mechanical properties must be there in order for it to work. However, there's always a concrete ramp for your pump. So for agitation, your pump will always go down on a concrete ramp, and that will protect it from where the inlet of the pump sucks in. And then typically where it's shooting out, the clay is strong enough to hold it. In terms of synthetic or plastic liners, they are really quite durable. I wish I was looking for my piece of liner here, but if I could show you, that liner is not, it's not a tarp. You couldn't tear it apart. In fact, when we do weld tests on it, we typically hang like several hundred pounds on it to do a weld test. So the HDPE liners are really, really rugged. We do protect them the same way with the ramps for your agitator, but just general like ice smashing into it, they're fine. They're really, really strong. In fact, if you go and look any of your municipal wastewater treatment lagoons in Nova Scotia, most of them are lined with either clay or HDPE. And they're always going like crazy because they have agitation systems that run, aeration systems that run 24/7.
Great. Okay. And I recognize that we are at the end of our time here. And so if anyone needs to leave, if they've got other commitments, then that's obviously acceptable. There's no additional questions coming from the audience. Oh, maybe I spoke too soon. Okay, we've got one here coming in from Duncan McCurdy. How do you agitate with a cover?
Right. So how you agitate with a cover is using air. So I wonder if I could find a picture online. I used to have one here. Agitation. Okay. I don't know if I have one. Anyway, basically what it is, because I actually helped build one of these ones. So when I worked for DGH Engineering, they had a subsidiary called NCON, which held a patent on this, on the negative air pressure cover. The patent has since lapsed. It's in the public domain. So here's how we built the agitation system. PVC pipe laid on the bottom in a approximately 30 to 40 inch grid. And on top of that pipe, and initially we used bicycle tubes. So the same thing you'd have in your 10-speed bike, snip them up, drilled a hole, slid the tube over it, slid the bike tube over it. So your bottom of your whole lagoon is covered by a approximately 1 meter by 1 meter grid of PVC pipe with little holes in it and a bicycle tube covering it. Then these are all connected up to a manifold on the at the edge of the lagoon, and up to that you hook a root style blower. So this is a high volume, relatively low pressure blower, and you blow the same kind of thing you see on a vacuum truck for septic, sucking out your septic, except it's blowing rather than sucking. So we had a 3-point hitch mounted one of those, hooked it up, and you ran it. And usually we'd run it for anywhere from, I don't know, 6 to 12 hours prior to pumping, and then run it while we were pumping the lagoon. Now, the last one of these I did, I was involved in out west, was a Hutterite colony. And it was, I mean, their lagoon was enormous. And so they actually had custom spread companies that would come out, and they had crews of 6 people that pumped ran drag lines and pumped those lagoons. So it's basically, it's basically an air agitation system. There's tweaks to that, but really there's not much more than that to it.
Okay, very good. And no other questions in the chat room. I have one quick one I'd like to put out there, but for any of these earthen manure storage systems that have been built in the past, that maybe some producers have concerns with the liner in, are there any kind of retroactive engineering techniques that you can use to test and or modify existing earthen manure storage tanks in order to kind of shore them up or ensure that they are holding the manure?
Well, that's a good question. There are retrofits for sure. So one of the things, if you were stuck in the very unenviable situation of having a problem with groundwater, so maybe a neighbor has identified the potential for a contamination, or you've noticed contamination in your own wells, geotechnical drilling and placing in piezometers, which are just a PVC pipe with perforated bottom, to check and see what you've got. Now, it's very difficult. This is a really difficult thing to do after the fact, because baseline water qualities, it can be all over the place. So that would be how you would find out if it was leaking, is basically some geotechnical drilling. That's going to cost a lot of money, and it's either going to give you a horrible answer or it's not something you're probably going to line up to do. Now, if you want to retrofit an existing earthen manure storage, I think there's probably kind of 2 or 3 phases that you'd want to look at. Like, some of it, you just look at it and say, okay, I got something that I know isn't very good. Let's try to make it like a good, better, best thing. Do you know what's better than a really bad one? Is a pretty good one. So if we look at that and just try to do a kind of performative improvement, some of the best improvements I've seen really are doing things like, say you've observed leaking at the toe of the lagoon. Okay. Or there's just structural issues. Well, you can shore the structure of it up. We can certainly go in there and do that, which would be involved, maybe making the berms wider, making them less aggressive slope on the outside. Definitely don't allow trees to grow on the berms. That's just going to perforate anything that's already there. So clearing vegetation off, big vegetation, grass is perfect. And the other thing too that I've seen a lot of, like that inside slope, really it should stick to a maximum of 2 to 1. We were able to build a lagoon here in Nova Scotia with a 1-to-1 slope. It was basically built out of almost rock, and it was obviously lined with poly. But a 2-to-1 slope on the inside, if I look back in my, these are things that are part of the regulations in other provinces. So in the prairies, it's 3-to-1. Well, they don't care because they have lots of land and it doesn't rain. And Ontario, 2-to-1 is probably, and I see that in most Eastern United States jurisdictions, 2-to-1 is a good safe slope. And the reason why, if you have a slope that's too steep, you're going to get basically erosion like this into the side. A 1-to-1 slope, 45 degrees, you'll potentially have the same type of erosion. So doing things to modify the slope, that'll help a lot. if you really want to go whole hog, then empty the lagoon and put a liner in it. But before I would do that, I would consider, why not consider maybe building a new lagoon or EMS.
Great. And we've got one last question. And again, it's Duncan McCurdy, and he's asking, would your, and I think he's referring to the forced aeration system that you alluded to in the previous question. And he asks, would that agitate sand-laden manure, or is that more applicable to hog?
It's $1 million question. I would not want to say that it would. And this is me saying sand-laden manure. It's like right up there with whatever the sun's made out of, plasma. Like it's understood by science only in an abstract format. There's a fellow down at Cornell University. I don't know what his name is, but he is Mr. Sand-Laden Manure, and it defies, because crazy stuff happens with it. And just not to get too deep into this, but most sand-laden mixed, like, water with sand in it, it'll have a strata. Well, manure can have like sand chunks floating on top of floaty stuff that precipitates out when you do other things to it. So I think it's a perfect place for somebody to do a master's degree or some good empirical research on a farm that's funded by one of our great agencies here in Nova Scotia. I would love to know. But yeah, it's one of those things that if somebody tells you that for sure it does, I would want to see real world data. Just as and I'll end it here because I can go on and on about this. We had a negative air pressure cover, the ones I mentioned, on top of a slurry store in one application. It was a really weird application, and it was experimental. And that guy had really good results. It was a slurry store. He had put the same aeration system that I talked about with the bike tubes and everything. It was out in Manitoba, and he had sand in his manure, and it worked pretty good. It worked better than the agitation system that came with the slurry store. Like, it had the mechanical agitation system built into it, and the farmer reported that our aeration system worked better. But yeah, that stuff is crazy. So, leave it at that.
Alrighty, if there's no further questions, I would like to thank you all for joining us here today, and thank you, Steve, very much for your excellent and informative presentation. If there are any additional questions that we didn't cover, or you would like to have answered after this presentation, please reach out to either Steve or myself, or Corey or Trevor. This presentation will be available as a recording, and you'll find that on the Perennia YouTube channel. Should be available in the next few days or so. We'll be sending out an email in the next couple of days as well, with a link to a survey. We would appreciate if you could take a few moments and let us know what you thought of today's presentations. If you have any comments or feedback or ideas for future presentations. I would also like to bring to your attention, we have 2 additional upcoming webinars as part of this series. The next one will be next week, February 18th. This will be, the topic will be supporting wild bees, and is presented in partnership with the Clean Annapolis River Project. On April 27th, we also have a presentation that will cover Nova Scotia water withdrawal program as it relates to irrigation. And yeah, with that, I'll leave you with our contact info, as well as the address for the Nova Scotia AEP website. I encourage you to check that out. So with that, I'd like to thank you all again, and that concludes today's webinar.